Just now we look at the non-uniform field. There's a formula, you have to memorize it and know how to use it. Now we are looking at uniform field. Right? Let's just review your Form 5 work. Potential difference. Right? Usually its symbol is V or PD between 2 points. Right? It's 2 points.
Potential difference basically voltage lah.
It's just voltage. It's the work done per unit charge in taking a positive charge from one point to the other. Take a positive charge from one point to the other. The work done divided by the charge. That's all. You take the charge from here to the other point. Calculate the work done divided by the charge. Okay? Work done divided by the charge. SPM work, and then it's measured in volt. Right? Measure in volt. Your page 22 in the new book. Old book, I don't know. Okay. So the unit is volt or joule per coulomb. Okay. Your SPM work. You will study more later on when we come to resistance again.
Okay. Yep.
Right? It's given a dry cell. Right? One terminal is positive, one terminal negative. That's your symbol for dry cell. That's for your battery, right? Cell in series. So you put your parallel conducting plate, or sometimes we call it capacitor. The terminal is positive. So this part will be red, positive. This part, the wire, black, will be negative. So you put a plate there. The electron will flow from the negative plate, from the negative terminal. It will flow to the plate there. The electron will repel an electron on the positive plate. Then the electron will flow back to the positive terminal. So now this will be positive charge. And then the process will repeat. More electron will come, repel an electron, and it becomes positive until the potential across the plate is the same as the potential of the battery.
Wait. Okay, teacher. First you say the electron, right, teacher?
Yeah.
Electron come from this positive plate, right? Correct, right?
Electron from the negative terminal flows to the negative plate.
Yes.
So it comes to the plate there, it must repel the electron here. So when it repel the electron here, it becomes positive there. And then the electron return to the positive terminal. And the process repeat until the potential is the same as the battery.
Hey, repel means not negative, Archer. I thought attract only positive.
Electron? Repel electron. So when you repel the electron, it becomes positive charge now. Then the electron will go back to the positive terminal.
Huh? Oh.
Yeah. Electron is attracted by a positive terminal.
Isn't there a connecting line, Archer?
Huh?
Isn't there a connecting line?
What connecting line? This one. This one is
no, the other one.
Your battery in series, that's all.
Because I remember STPM, right? Because they have complete.
That's empty. Right? Can be air. We call it insulating layer, air, or dielectric. Yeah.
Okay.
Insulator, not conductor. The two plates are conductor.
Okay.
Yeah. Just new thing you have to learn, that's all. Can't be learning all the old things. You have to learn new things, new ideas.
So I mean it goes to the negative plate and then electron will like repel. So it will go to the it'll become positively charged, right? That's it.
Yeah,
that's why
the top become positive charge, bottom become negatively charged.
Wait. So from the bottom it goes to the positive, right? That's
bottom is negative charge, repel the electron. So the top become positive. The electron is attracted to the positive terminal of the battery. That's all.
Oh, okay. Got it.
Right. So usually the layer of air is very thin, or we call dielectric. Usually it's air. Right? That's what we tell you just now. Right? Electron is the one that is flowing. from this positive plate to the positive terminal. It flows on the negative terminal to the negative plate. That's all. As it flows, it repels the electron on the positive plate. Okay with that?
I'm okay with that.
Right? So usually it's 3 dimension. Right? It's not just a thin like that, it's a plate. That's your plate. Okay. Remember, the charge will repel each other. So they will be evenly spaced. Right? The charge is the same. But bottom is negative Q, top is positive Q. Right? One electron repel one electron, you get a positive charge. So the total charge on the top plate equals the total charge on the bottom plate. They are the same, except bottom is negative, top is positive.
Only their charges.
Charges different, that's all. Right?
Okay, but their value is the same.
Value is the same. The positive charge, we remember our few lines start from positive and negative, end on negative. Then a positive, the line will end on a negative. So we can draw, the line will be evenly spaced, right? Because the charge are evenly spaced. That's all. So we are called uniform field. Okay with that? Nothing much, just know to memorize, that's all. New things you are studying.
Yeah, it takes some time to digest larger.
Yeah, go back and digest. So
Okay.
we are just using basic idea that we have of the field. So between the plates, the field line is strong.
Okay. Now I
Uniform.
understand.
When the lines are parallel, it's uniform. You leave the plate perpendicular to the plate and enter the negative plate perpendicular to the page. That's all. Right? We are using our properties of electric field.
Isn't it parallel, Archer?
Yeah, parallel, evenly spaced.
You put that perpendicular, ma.
Perpendicular to the surface. Listen carefully. Perpendicular to the surface, but they are parallel lines. It's perpendicular to the metal surface. Right? It starts from positive and end on the negative charge. Evenly spaced. That's all.
How are they perpendicular to the plate? They are parallel, what?
Yeah. Okay.
No, teacher, because that they show parallel, they never even show anything perpendicular there. That's why I'm asking.
Perpendicular to the plate. The plate is horizontal. What's the problem? Plate is horizontal. Parallel means perpendicular coming out, coming down. That's what it means by perpendicular to the surface.
Oh.
Yeah.
Okay.
Perpendicular to the surface. Not perpendicular to each other. They are parallel to each other, but they are coming out perpendicular to the surface. Enter perpendicular to the surface. This is the surface, horizontal.
Oh, okay. Yeah, they are. That means their plate is perpendicular, but the lines are parallel.
Yeah,
right?
you leave the surface perpendicular to the surface. That you must know. That's your SPM work. You enter the surface over perpendicular. Uniform within, if it is uniform, means that at any point, you can take any point A and B. Right? Magnitude is the same. Direction is still the same. That's what I mean by uniform. At A and B, the value is the same. Direction is the same. Right? The strength is the same. That means anywhere inside between the conductor, the electric field strength is the same. Yeah. Memory work, nothing much. Just new thing you have to learn, that's all. I teach you, then you go back and review through yourself. Then you see parallel lines, then the field is uniform field. That's all. Uniform field means that at any point within the field, the strength is the same. The magnitude is the same. The direction is the same. Yep. What's the problem?
No, I mean you can continue, sir.
Right? Same like gravitational field. Near the Earth's surface, your gravitational field strength G is the same, right? All have this parallel and equal distance apart. That's why we study last semester. So an object will accelerate downwards or move from a high potential energy to low potential energy. Same, we are using the same idea for electric charge, right? So we can have different ways of looking at the problem, right? Remember, I stress it, there's a potential difference. Call it delta V or V. Delta V or V, potential difference of voltage across the plate. So it's always the positive plate, V plus, minus V minus. D is a separation. So we can derive, we can look at the different way of viewing the problem. Top plate there, positive potential, so it's high potential. Lower plate, negative potential, lower potential. So we can think of, if you put a positive charge, it's repelled by the positive charge up there. That's why it accelerates downwards. Right? Light charges repel. Or you put a negative charge at the bottom there, it's repelled by a negative charge, it accelerates upwards. So positive and negative charge behave differently. Right?
So,
If we
again?
Yeah, what's the problem?
No, I just want to this one. Okay, the upper plate has a high potential. Oh yeah, that means positive means, yeah, that means the potential difference is high lah, and then the low one is potential difference is low because it's negative. So experience a repulsive force, and then it will accelerate to the lower plate, and then charge will repel. Oh, same lah. That means the negative one then will repel and then go to the positive plate, something like that also, right?
Same idea, same idea.
So this is just opposite only, but
You're
same
just
lah.
applying what you have learned in your SPM, that's all. Charge repel, positive charge repel, positive charge, negative charge repel, negative charge, or attract positive charge.
Okay.
Right? You can look in terms of energy. Right? High potential top plate, positive plate high potential, low plate is low potential. And so if it's a positive charge, remember positive charge is a high potential, it must move to a lower potential. Yeah, move downwards, repulsive force. Or electron, right? Electron near the lower plate, repelled by the negative plate, so it must move upwards there, or we say it move from a lower potential to high potential. That's all. Way of expressing the same idea, either in terms of energy or force. Okay, stop me if I'm going too fast. Give you time to digest.
Wait, just now one was low to high, now it's high to low.
Positive charge is from high to low. Negative charge from low to high.
Ah, okay. Yeah, okay.
Have a repulsive force and learn from there. Right? Gravitation, one mass only, no positive, no negative. That's why the mass will go from a higher potential energy to lower potential energy. But electric field is different. Electric field got positive charge and negative charge. That's why a bit more confusing. You not think of it in terms of force. It's okay. Can read yourself and then digest it yourself. Right? That's the relationship. V divided by D. So we can derive that. Right? The electric field E. There's a charge Q. Right? Near the top plate there. You move a distance D. So if the charge is placed near the top plate, the force is just your, from a definition, force is electric field times your charge Q. Okay, so the direction of the force. So if you move a distance D, then your work done is force times your distance. Then we go to our definition of electric field. So we can replace our F with EQ, E and then EQ times your D. Then you want to calculate the electric field strength, right? Or potential difference. Potential difference is just your work done divided by charge. We always use definition, right? We'll calculate the work done. That's our work done. Divide by our charge. Put inside the equation. Inside our
EV
Q.
lah.
Then we got ED. That's a formula.
Another derivation.
Mm.
Wait, answer 1 minute. Q experience force. So the force equation is EQ lah, teacher, actually. Then substituting into W equals to FD, then you get that. Then the voltage V equals to work done over charge. So that's why
I
you
just
get
calculate
EV
the
lah.
force, right? EQ, and the work done is just the force on the charge times the distance moved by the charge. That's all. So I replace that force there with my EQ here. After that, I want to find the relationship between voltage and electric field. That's my definition. Potential difference of voltage is W divided by Q. Right? So it's EQD divided by Q. Okay, now what's the problem? No potential.
No, I'm okay.
If defined as that. Yeah, so that's where I get my formula. Yeah. How E and V are related. Yep. What's the problem?
No, okay, can proceed, sir.
Right? In terms of the graph, electric field strength, how does it vary with distance? And how does the potential vary with distance? Same thing. Usually we take the positive plate as our origin. The electric field strength, we say uniform, right? Our origin, and then x direction is downwards. And then the potential at any point x is V. Right? So electric field strength, we say uniform means it's constant. There's horizontal line, it doesn't change with distance. Horizontal line. Whereas the potential difference decreases. Right? That's what we say. It's a straight line. As I it decreases, upper plate positive, bottom plate negative. So it's go downwards from positive to negative. That's all. Right? A straight line. You want more mathematical, right? V plus minus your V equals to E x is a distance. Right? The distance downwards there. And then rewrite that. Your V, right? Take to the other side. E minus x to the left. You get this formula. That's why we get a straight line. Just memorize the graph. Uniform field, horizontal line. The potential difference decreases from positive to zero or negative plate. Yeah. Okay or not?
Electric field against distance is just a straight line, and then potential difference against distance, it's Huh.
Just know for this equation, it's a straight line, that's all. Nothing much.
Okay.
Right? So this summarize for you all the formulas that you need to know for this topic up to electric field. That's for your first part, 12.1. 12.2 is just that. Right? These are extra formula that you need to remember. And then that's your next homework. Yeah.
Hey, wait. So this one also another homework.
Yeah.
Wait. Okay, got it. Okay.
It's just in your book, 12.2. Go and get your book.
Yeah. So can you go to the 12.1 again?
Say again.
The homework you want me to do? No, the homework you wanted me to do the slide. I just
I'll send you
maybe I
the
might
slide.
lost.
I'll send you the slide. They can go and do from there. Can go and check from
The
there.
I mean the homeworks you want me to do, right?
Yeah.
Okay. So not okay.
Okay. You can just review yourself. Let me just go and do some example for you so that you know how to do your homework. Okay. Let's try this question. You can try that. Sorry. A first. This one. 8.4 microcoulomb. 8.4 microcoulomb is introduced at a point in the electric field or intensity. That's the strength of the electric field. What is the magnitude of the instantaneous force on the charge and the direction? Yeah.
Oh, okay. This one is the electric field one, right? So,
Let's go to the definition.
yeah, force over charge lah. So 120 equals to F
E
over
equals to
8.4
force
times
over
10 to the
charge.
power 96.
Just playing with the formula. That's all. Can?
Yeah, you use that formula.
Yeah. E equals to F
Oh
over
yeah,
Q.
yeah. F over Q lah, correct lah. Yeah.
That's what physics is all about. Playing with formula. And always remember the line is the direction of the flow of positive charge. So the force is downwards, or the top there is positive, down there is negative. So that's why it's a repulsive force. Different way of getting the direction of the force. Yeah.
Okay, then.
Then on the
Direction
electron,
of the force.
where's the direction of the force on the electron? Yeah, we should be able to do that. Just applying what we have learned. Right, on the stationary electron there, where's the force? Yeah. Can or not? Electron is
Wait.
upward is positive, downward is negative.
Now, how do you do that, Ajay?
How do you do that?
I mean, direction of force, how to show.
Direction of force is always the same. You have studied in your SPM. The force on the positive charge. So the line basically show you the direction of the movement of the positive charge. So if you have a positive charge, it's always follow the line. Negative charge is opposite to the line. That you must know. Memory work. Or the top part is positive. Right? The top part is positive. The line starts from positive charge to negative charge. All this you must know. Your SPM work. Just applying only. So the top is positive, bottom is negative. So there's a repulsive force. That's why it's going downwards there. Electron is going upwards there, attracted to the positive plate. Okay.
Okay.
There's the other question. You have a charge there for times 10 to the power minus 16 coulomb, placed in a uniform field, and you are given the force. They are asking to calculate the strength of the field. Yeah, just playing with the formula. E equals to F over Q, that's all. Should be able to play with the formula. Yeah. Then you should be able to know where's the direction of the force. Yeah. Okay. Yep. What's the problem?
No, okay, I review first. That's it, right?
One more question. After that, we will finish the class.
I think I absorbed too much already today.
That's why I say if you can distribute 1 hour weekday, 1 hour weekend, then it's easier. Especially where you have to. Okay, let's try this question. Right, to show you how to apply. You are required to know how to calculate, but we are not going to calculate. Just going to find the resultant. We got two positive charge at A and B. And then this is an equilateral triangle. So you want to find the electric field at C. This is the point C. Due to that one, the positive charge at A. So you just join the line. And then at C is going outwards there. Follow this line. Right, along AC. Produce. That's all. Then the electric field at C due to charge at B. Right? Remember, it's going out from the positive charge. And then there. Then you complete your parallelogram. And then you get a resultant field. It's straight to the top there. Okay with that? Any comment?
Hey, go again, sir.
First, you want the positive charge. You want the electric field at C. So,
yes,
just join the line there. It's directly coming out, and at C, it goes straight through AC, and AC is produced. That's all.
Oh, and then the other line?
After that, the other one, due to this positive charge, is going out from the positive charge. So at C is going away along BC, produce.
No, the one the B part is for B lah, right?
So these are the two vectors. So to find the resultant,
then the
parallelogram.
Yeah, the EA plus EB plus EA, then it's a straight line lah from the C point.
Yeah, the same magnitude. Because the same distance away, same magnitude. So complete a parallelogram. Calculate your resultant. That's how you calculate your resultant.
Oh, yeah. Now I understand. Okay.
Yeah. Then you should be able to tell me for this one. I'm just the same thing. Equilateral triangle. I just change to negative charge. So where's the resultant force?
Okay. Let me try that. They put the positive Q, negative Q. So they want electric field at C due to charge at A alone. EA minus. EA minus. They put the. Yeah, A minus. Okay, the A. Teacher, the C is facing towards the A.
No, it's just a vector. Due to this positive charge, it's still going away. Then due to the negative charge, it's going downwards there. Instead of going upwards
It's
there, it
far
comes
away
in towards the
lah.
negative charge. That's all.
Yeah.
Magnitude is the same. We just form the parallelogram,
Yep. And then you get
and there's
yep.
a resultant.
Mm.
That's all.
Yeah. Got it. Okay.
Okay. So as I said, you learn new things. You have to try the exercise to reinforce it in and know how to apply. To solve the problem is how to apply. So that's why I give you the homework to try it out. So I'll send you the slide.
Okay.
Okay, we finish for today. We'll see you next week.
Yeah. Next week. Okay, teacher. Thank you.
Okay, bye bye.
Bye bye.